Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to the Natural Science lesson. My name is Tobegile Tebe, and this program is proudly brought to you by the Houghton Department of Education. What's our topic today, grade 8? We are continuing with visible light, and today we are going to be focusing on opaque and transparent substances and reflection of light. And then before we do anything, we have to set a goal for ourselves. We need to achieve something by the end of this lesson. What is it that we're going to achieve by the end of the lesson? Let's look at our lesson objectives. We are going to distinguish between opaque and transparent objects. And we're also going to compare the different colors and the effect they have on different objects. And we're also going to determine what happens when light is absorbed by different surfaces and how this produce different colored objects. We want to see how these produce different colored objects. All right. And then we get all this from the CAPS document that is on page 50. And then let's look at the pre-knowledge. What do we know on this topic? Remember in grade 7, you did what? You did the transfer of energy, and you're focusing on solar energy. All right? And then you know that the sun is the ultimate source of energy. And it helps us a lot during what? During photosynthesis. Because plants need photosynthesis. You still remember that, don't you? That's good. Let's go on. Let's just refresh our minds. Let's write a baseline activity. I've got question 1 here. It says, name the colors of the visible spectrum. And then question number 2 says, identify 3 primary colors of light. And the third one is, which color of light has the longest wavelength? I'll give you 2 minutes to answer the questions. All right, grade 8, hope you are done writing the exercise. Let's do it together. Name the colors of the visible spectrum. Remember the colors of the visible spectrum. We've got which colors? We've got red, we've got orange, we've got yellow, green, blue, indigo, and violet. And we make it simple by saying Roy G. Beef. All right. If you say Roy G. Beef grade 8, you'll never get it wrong. because you know the R is standing for what? For red. Then O for orange. Then yellow. Then green. Then blue, indigo, and violet. That is Roy G. Biv. All right. And how does this happen? Remember, the spectrum comes from what? From the white light. If the white light strikes a what? A glass prism. I've got a picture here of a glass prism. If white light, this is white light, strikes a glass prism, what happens? Then the light is going to refract. When we say light refracts, it will be bending, and then it will split, and then we will see the colors of the rainbow. And these colors are red, orange, yellow, green, blue, indigo, and violet. These are the colors of the spectrum. All right. But when we just see white light, you just see white. But you must know that there are many colors in it. All right. Then question number 2 wanted you to list the 3 colors of light. The 3 colors of primary light. And these are red, green, and blue. And these are different from the colors of paint. All right. The primary colors of light are red, green, and blue. Make sure you take note of that. And then, which color has the longest wavelength? If we're talking about the longest wavelength, grade 8, do you still remember what we're talking about if we're talking about the wavelength? All right, this is the wavelength. All right, when we are talking about waves, then the wavelength, this is the top of the wave, this is the crest, and here this is the crest. And then the distance in between these 2 consecutive crests is called the wavelength. All right, and then we've got a crest, a throw here, and a throw here. The distance in between these 2 consecutive throws is the wavelength. All right, and then the color that has got the longest wavelength is red. Do you get it? It is red. Don't forget this. All right. And this one happens when we are carrying out our experiments. And in nature, what's going to happen? Remember the rainbow. What would have happened? It is the white light that will fall on what? On a raindrop. And then it will refract. And then it will split, forming a rainbow that we normally see after it rains. And even if you visit a waterfall, you may see a what? A rainbow. Okay, this is the power of light. Okay, let's carry on, grade 8. Let's define terminology. Remember, in each and every lesson, we come across new words. Therefore, we need to define these words so that it will be easy for us to understand the lesson. All right, let's define the words together. We've got opaque. What does the word opaque mean? Grade 8. All right. Opaque means a substance that blocks the path of light. It blocks the path of light. For example, my hand is opaque. Why am I saying my hand is opaque? It is opaque because light will not travel through. It blocks the light. Therefore, we say it is opaque. And then, if light doesn't penetrate through an opaque object, what's going to happen on the other side of the object? There's going to be a shadow. Why? Because the light doesn't pass through. And then if the light rays are wider, what's going to happen? Light is going to travel on the other sides of the object, causing a what? A shadow. You get that? And then let's go on and define some more terms. We've got transparent. If we are talking about transparent, what are we talking about? We are talking about a substance that allows light to pass through it. For example, if you take clear plastic, it is transparent. You can see through it. Therefore, it allows light to pass through. Even the windows in our classroom, if you can see an object outside, it means that the windows are transparent. therefore allowing light to pass through. Do you get that? That's very good. Grade 8. Let's carry on defining the what? The terms. And then we've got absorbed. When light is not reflected to our eyes, for example, a black object, all right, it absorbs the colors of the spectrum. Okay, when white light shines on a black object, what's going to happen? All the colors of the spectrum will be absorbed. No color is going to be reflected to our eyes. Therefore, our minds are going to interpret this as black. Do you get it? Because no light is going to come to our eyes. Okay, the colors will be absorbed. Let's carry on. And then we've got a moon and the sun. Remember, the sun is an illuminated object. The sun is a illuminated object, meaning what? If it is illuminated, it emits light. It gives off light. But what about the moon? The moon is illuminated. All right. Therefore, it does not emit light, but it reflects light from the sun. The sun is a illuminated object. It emits light. It gives off light. And then the moon is illuminated, meaning it only reflects light from the sun. Do you get it? And then, if the moon is illuminated, what's happening to it? It gets the light from the sun, and then we will see a what? We will see a full moon. But if the moon is in between the sun and the earth, it's going to block it. And then we are going to see what we call a full moon, because it will be dark. Okay? It would have blocked it. And then at times, if it is illuminated 50%, the half of the moon will be reflecting light and the half will be dark. And even if it reflects what? A quarter, then the 3/4 will be dark. And if it reflects 3/4, then the quarter will be dark. Do you get it? Good, grade 8. And then let's look at opaque and transparent substances. Okay, remember, when we're talking about opaque, we are talking about those objects or substances that do not permit light to pass through. But when we are talking about transparent, we are talking about those objects that permit light to pass through. For example, transparent windows, even clear plastic. All right? These are transparent. You can see through them. It means they will allow light to pass through. Do you get that, grade 8? That's very good. And remember to send questions on our WhatsApp line. If you don't understand something or you want to ask something on this topic, make sure you send us a message on 064 748 8913. The number again, 064 748 8913. Please ask the questions if you don't understand. Please do not call this number. It's only for messages. All right, let's carry on. An opaque object is an object that does not allow light to travel through it. Can you give an example of an opaque object, grade 8? Think of an example of an opaque object in your classroom. Okay, that's very good. There are a lot of opaque objects in our classroom. Our books are opaque. Our tables are opaque. Our chairs are opaque. Even our hands, they are opaque because you cannot see what is on the other side. Why? Because light cannot pass through. Do you get it? The light cannot pass through. The opaque object blocks the rays of the light. Okay, it blocks them. Therefore, light cannot travel through. And then, light travels in straight lines. What do we mean if we say light travels in straight lines? If you look, maybe you are in a forest and then you see light coming in. You will see it coming in straight lines. it travels in straight lines. Do you get it? That's very good. When light rays strike the surface of an opaque object, the light rays are blocked. Always remember that. When light rays strike an opaque object, then the rays are blocked. Light cannot travel through. I said our hands are opaque, therefore no light can travel through. But what's going to happen if light is blocked? It is going to cause a shadow on the other side of the object. Do you get that? That's very good. And then light is either reflected or absorbed by what? By an opaque object. It is either reflected. For example, we've got a good example of a moon. A moon will reflect her light from the what? From the sun. All right? It reflects it. And then in other objects, it is going to be absorbed. The light is going to be absorbed. Let's talk of a black substance. What's going to happen if white light shines on a black surface? The colors are not going to be reflected, but the colors are going to be absorbed. That's why in winter we put mostly on black clothes. Why? Because they absorb the light. Then we'll feel warm. All right. What will happen if you put on a black cloth on summer? What's going to happen? You're going to feel hot. Why? Because it does not reflect light, but it absorbs it. Okay? It will absorb the light, causing you to feel warm. All right. That's why in summer mostly we put on white clothing. Why? Because it will reflect all the light back. It does not absorb it. It reflects it. Okay. All right. Light travels in straight lines. When light rays strike the surface of an opaque object, the light rays are blocked. And then light is either reflected or absorbed by an opaque object. If the light is absorbed, it means that the light is unable to travel any further once it has reached an opaque object. Why are we saying it won't travel any further? Because the opaque object is going to block the light. All right. When it blocks it, what's going to happen on the other side? There is going to be a shadow. Then this light won't travel any further. Why? Because it has been blocked. And then we've got good examples there. We've got pictures there. We've got blue surface there. What happens when white light strikes a blue object? Remember, the colors of the rainbow are the colors of the what? Spectrum. All these colors will be in white light. That is Roy G. Biv. And remember we said Roy G. Biv is what? It's red, orange, yellow, green, blue, indigo, and violet. And then when white light strikes a blue object, what's going to happen? The other colors are going to be absorbed, but the blue color is going to be reflected to our eyes. That's why we will see that object as blue, because the blue has been reflected to our eyes. And then what will happen to the other colors? They'll be absorbed. That's why we don't see them. Do you get it? That's very good. And then let's look at red. Okay? This is white light. This Roy G. Biv. It is white light. It will strike a red substance, and then what is going to happen? The red is going to be reflected to our eyes, and then we will see that substance as red. Is that clear? That's very good. Great. 8. And then what will happen to a white object? What's going to happen? Think of what is going to happen. Grade 8. All right. If white light strikes a white object, all the white light is going to be reflected. No light is going to be absorbed. It will all be reflected. That's why we will see an object as white. Do Do you get it? And then let's look at black. All right. What happens when white light strikes a black object or a black surface? All the light is going to be absorbed. And if it is absorbed, what is going to happen? No light is going to be reflected to our eyes. And therefore, we will see the object as black. Do you get that? If white light strikes a black object, all the colors will be absorbed. No light is going to be reflected to our eyes. And therefore, our brains are going to interpret it as black. You get that? Why? Because all the colors of the spectrum will be absorbed. Let's get on, grade 8. Let's look at opaque and transparent substances. Light rays that are wider than the opaque object will carry on around the object, causing a what? Causing a shadow to form. All right. Let's say this is my hand. It's an opaque object, remember? And then when light shines on it, light is going to be blocked. Okay. But if the rays are wider, what's going to happen? They are going to go on the other side, causing a what? A shadow at the back of an object, or at the back of my hand. There's going to be a shadow. For example, let's look at these pictures here. I love these pictures. Let's look at this hand. Okay? It is opaque. It doesn't allow light to travel through it. And then what happens as a result? If the light rays are wider, it's going to cause a shadow. You see this shadow? This is the shadow of this hand. Okay. Why? Because the hand is opaque. It doesn't allow light to travel through. And the light rays are wider. Therefore, they cause a what? A shadow at the back. And then even these buckles, they are opaque. Why are we saying they are opaque? Because they are blocking light. Light cannot travel through them. That's why we've got these shadows. Do you see these shadows, grade 8? It is because these buckles are opaque. Therefore, there will be shadows. Okay. Even all these images, it shows that our hands are opaque. And then, as a result, they will form a what? A shadow. You see these shadows? They are caused because our hands are opaque, or because the object is opaque. Okay. Shadows are darker areas. These are darker areas. If you check this one, then this one, all of them, they are darker areas that form behind an opaque object because the light is unable to travel through the object. You get that? That's very good. Then the shadow takes its shape from the shape of the object and will form on the side facing away from the light source. For example, look at this hand. This one has got a clenched fist, and then the shadow is showing exactly that. All right. And then check the buckles. They take the shape of the buckle. The shadow takes the shape of the buckle. Okay. Let's carry on. And then we are still talking about opaque and transparent substances. When objects are far away from the light source, a smaller amount of light is blocked, and therefore the shadow is smaller. If the light source is far, what's going to happen? The shadow is going to be smaller. But if the light source is near, the shadow is going to appear big. Do you get that, grade 8? That's very good. When the object is closer to the light source, more light is blocked. Okay. That's why we are saying the shadow is going to be bigger, because there is more light that is being blocked. But if the light source is far away, just a small amount of light is going to be blocked. That's why we are going to experience or see a small shadow. Okay, Therefore, when you compare the shadow of an object that is near a light source and the other that is from a source of light that is far away, you'll see the shadows are not going to be the same. The one that has got a closer light source is going to appear big. Why? Because the light rays are being blocked. Okay. And then the one that has got a light source that is far away, the shadow is going to appear small. Do you get that? That's very good. Let's check our picture here. We've got two lights. We've got this one and we've got this one. These are the two lights. Let's look at the lights and the objects. All right. This one that is near the object, see how the shadow is going to appear. It's big and it looks very dark. And this one that is a bit far, it is faint. And then this one from a far light source, how is it going to appear? It's going to appear very faint. You see that? That is what we mean about the light, if the light source is far and if the light source is closer to an object. Okay. And then let's continue with opaque and transparent substances. Remember what we said about opaque substances, grade 8. We said opaque substances don't allow light to pass through, but they block the light. And what about transparent objects? They allow light to pass through. Do you get it? For example, in our classroom, we've got windows. If we can see images outside the windows, it means that light can pass through. But if our windows are opaque, we won't see anything outside. Therefore, it means that light cannot pass through. The light is being blocked. You get that? That's very good. All black objects absorb light. So no light will travel from that object to your eye. Why are we saying that? If white light strikes a black substance or object, there is no light that is going to be reflected back to our eyes. You get that? Remember, we only see light, the color of an object, because light is being reflected to our eyes. If it is not reflected to our eyes, we are not going to see that color, but everything will appear black. Why? Because our minds are going to interpret it as black. Even if you close your eyes, what's going to happen? You won't see anything. All right? If you can't see anything, then the mind is going to interpret it as black. You get that, grade 8? I love that. All right, let's carry on. When no light waves reach your eyes, your brain interprets this image as what? As black. And then your brain can interpret the different wavelengths of light as different colors and can build a picture of what you see. You see the power of light and the power of the mind. The mind is going to interpret differently. Okay. If you cannot see light, if there is no light that is reflected back to your eyes, you won't see anything. Then that substance is going to appear black because no light has come to your eyes. Okay. Shiny light colored substances will reflect light, while dark colored substances will absorb light. Okay. If a substance is white, it's going to reflect all the light back. Okay. Remember, we're talking about white light. If it strikes a white substance, then all light is going to be reflected black. Okay. It's going to be reflected back. And then we are going to see white because all the colors have been reflected. And if it is a black substance, what's going to happen? If the white light shines on a black substance, and then all the colors of the visible spectrum are going to be absorbed. If they are absorbed, won't see anything. Why? Because no color is being reflected to our eyes. We can't see any color. And then our minds are going to interpret it as black because we can't see any color. No light is coming to our eyes. Okay. And then let's look at these pictures. We've got white light coming into a what? Into a black substance here. This is a black substance. And then there is no light that is being reflected. If it is not reflected, what does it mean? It means that all the light has been absorbed. Okay. Therefore, no light is being reflected to our eyes. And then let's look at this one here. White light is coming in, and then it hits a what? A yellow surface. And then what's going to happen to our eyes? We are going to see yellow. Why yellow? Because yellow is going to be reflected to our eyes. Therefore, we'll see this substance as yellow. Look at that. This is interesting, isn't it? That's very good. And then we are carrying on with opaque and transparent substances, grade 8. And by now, I think you now know the meaning of opaque and transparent. Just tell your friend what opaque means, what transparent means, grade 8. That's very good. If we're talking about an opaque substance, we are talking about a substance that doesn't allow light to pass through. It blocks the rays of light. That is opaque. For example, our hands are opaque. Why are we saying they are opaque? They don't allow light to pass through. They block the light, causing a what? Causing a shadow. All right, this is opaque. And what about transparent? If we're talking about transparent substances, we are talking about clear plastic or even clear glass. For example, in our classroom, we've got windows. And some of them are opaque and some of them are transparent. If they are transparent, it means light is traveling through them and you can see the objects outside. Okay, that is transparent. Make sure you know these words. Okay, and then the phase of the moon is due to shadows being formed. Okay, when we are talking about the phase of the moon, we are talking about different phases. At times, if it is 50% illuminated, we can just see a half moon because the other one will be having a what? A shadow. And then if it is a what? A new moon, it will be dark because it will be in between the earth and the sun. Okay, then we call it a full moon. And then if it is, for example, a quarter, then the 3/4 will be dark. And then if it is 3/4, then a quarter will be dark. You get that? All right. And then if it is a what? A full moon, we are going to see the shiny side. Okay. And if it is a new moon, it will be dark. Okay. When the moon is directly between the sun and the earth, we see only the black side of the moon. The illuminated side is facing away from us. This is called a what? A new moon, because it will be dark. Let's just look at this picture here. You can see it's very dark. Okay, it means that this moon is in between the earth and the sun. All right, and then we are only seeing the dark side. We're only seeing the shadow. It is facing away from us. Okay, and we call it a what? We call it a new moon. Okay, let's carry on. Grade 8. And then still on opaque and transparent objects. When the earth is directly between the sun and the moon, we can see the whole of the lit surface of the moon and the shadow side is facing away from us. This is called a what? A full moon. Okay, it is a full moon. This is a full moon. It's shiny. And then why are we saying it's shiny? Because it is reflecting light from the sun. And then let's go to transparent. Remember what we said about transparent. It allows light to travel through. We can see through a transparent object. For example, the glass doors or the windows that are transparent. You can see an image outside. It means what? The light is traveling through. For example, let's look at this glass door. This is interesting. We can see the images outside. We can see trees. It means light is traveling through. Okay. And then it means it is transparent. Why? Because no light is being blocked. Okay. A transparent object is any object that allows a transparent object is any object that allows light to travel through it. Okay. Transparent substances such as a glass, clear plastic, and even clean water allow all or the most of the light rays to pass through them and therefore do not have noticeable shadows. You won't see noticeable shadows. Even if they are there, they'll be minimal. They'll be very small. They'll be barely noticeable. Okay. And then transparent substances transmit light. Some of it is being absorbed and some of it is reflected. Okay. Which is why we see our reflection in a pane of glass. Okay, why? Because it is being reflected. If you look at the windows, at times you can see your image. Why? It is because of the reflection. And then most of the light energy is transmitted, which is why we see through transparent substances. For example, this glass door. Okay. And then we've got our activity, which we are going to write grade 8. The first question says, what is an opaque and transparent object? Question number 2 says, what happens when an opaque object is moved away from the light source? What happens when an opaque object is moved away from the light source? And then question number 3, why do we see a black color? Why do we see a black color? These are the questions. Let's write them. I'll give you 3 minutes to answer the questions, grade 8. I hope you are done writing the activity grade 8. Let's check the questions together. What is an opaque and transparent object? Then question 2 says, what happens when an opaque object is moved away from the light source? Then question number 3, why do we see a black color? Let's check our answers. And then it's going to be interesting if you can take a photo of your work and send us on 064 748 8913. 064 748 8913. Would love to see how you wrote your activity. Let's check the answers together. Question number 1. The answer is an opaque object blocks light from passing through. Remember what we said about an opaque object. My hand is opaque, then it will block light from passing through. All right. Therefore, it will cause what? A shadow at the other side. But an opaque object blocks the light from passing through. And then a transparent object allows light to pass through. For example, a clear plastic, all right? A transparent window that will allow light to pass through, and then you can see images on the other side of the building that is transparent. And then the shadow formed will become small. Let's check the question there. For question 2, what happens when an opaque object is moved away from the light source? What happens? Let's check. All right. If the light source is moved away from an object, what's going to happen? The shadow formed will become what? Small. But if the light source is near, what's going to happen? The shadow is going to appear bigger than when the light source is far. Okay. And then let's go to 3. All black objects absorb light. All black objects absorb light. Why are we saying all black objects absorb light? It is because there is no light that is being reflected to our eyes. Okay. And no light will travel from the object to your eye. When no light is reflected to your eyes, you will see what? You will see black. All right. Why? Because our minds are going to interpret it as black. And then absorption of light. Not all surfaces not all surfaces reflect light. Light can be absorbed by some materials. Some materials absorb light waves or certain wavelength from the visible spectrum. And then light is also absorbed different by different materials. A mirror, for example, will absorb no light. The mirror won't absorb light. While a colored piece of cellophane will absorb all the colors except its own. And then a material has color because it absorbs some of the colors in the spectrum and reflects their colors. For example, we've got a green leaf here. White light is going to hit a green leaf, and then what's going to happen? The green is going to be reflected to our eyes. That's why you will see a green leaf. That's how we are going to see a green color. You get that? That's very good. I love that. And then absorption of light again. If some of the colors in the visible spectrum are absorbed and the rest are reflected, then the object will appear what? To be the color of the reflected light rays. Okay. If white light strikes a blue substance, what's going to happen? The blue substance is going to appear blue. Why? Because the blue color is going to be reflected to our eyes. Therefore, we'll see blue. Okay. An object such as a piece of white paper looks white because most of the light in the visible spectrum is reflected back and very little is absorbed. Okay. A black object looks black because all the frequencies of light are absorbed and not reflected. Therefore, no light reaches our eyes. That's why you will see an object being black. And then these are the examples of absorption of light. All right. Especially on opaque objects. If white light, that is ray GBF, strikes a blue surface, what are we going to see? We are going to see the blue color. Why the blue color? Because the blue light is going to be reflected to our eyes. And even if it's red, we are going to see red. Why? Because red is going to be reflected to our eyes. And then white color, we're going to see white. Why? Because all the colors of the visible spectrum are going to be reflected back to our eyes. Okay, therefore we'll see white. And then black, we won't see anything. All the colors of the visible spectrum are going to be absorbed. Therefore, we will see what? A black. If it is green, for example, green leaf, if white light shines on a green leaf, what are we going to see? We're going to see green because green is going to be reflected to our eyes. You get that? That's interesting. In the previous grades, you learned about the effect of color, remember, on the absorption of what? Of heat. White or pale colors, they are cooler, and dark colors are what? They are warm. Okay. That is because light carries what? Light carries energy, which causes what? Which causes heating. So when more light is absorbed, there is a considerable heating effect. And when an object has a specific color, it is because it reflects only that color. That is the color that is being reflected to our eyes. Therefore, we're going to see that color. Absorbed colors of the visible spectrum are the ones that you will not see. Those will be absorbed. But the reflected ones, you are going to see. Okay. And then we've got activity 2. I want us to quickly write activity 2. I'll just give you 2 minutes to copy activity 2. Then we're going to do it together. Hope you are done grade 8 writing your activity. Explain why a car looks blue. Why would a car look blue, grade 8? It is because if the white light strikes an object and then blue is reflected to our eyes, therefore we'll see it as blue. And then number 2, explain why everything appears to be black when you close your eyes. Why is everything appearing to be black? It is because there is no light that is being reflected to our eyes. That's why you will see everything as black. And then what will you observe if 7 torches, each shining light of only one of the 7 colors of the rainbow, shine their light together on the same spot? It will be white because it is white light. You get that? Remember, white light contains all the colors of the visible spectrum. Okay. And then these are your answers. Okay. The blue light of the visible spectrum reflects on the car while other colors are absorbed. And then 2, when you close your eyes, no light can enter the retina. The brain interprets the absence of light as what? As black. And it will, question number 3, it will form a what? A white spot. Let's carry on. Let's go to our summary, grade 8. Light cannot travel through opaque objects. Okay. Light cannot travel through opaque objects. If the light source is this side, and then I put my hand, then light won't travel through because my hand is an opaque object and it will block the light, therefore causing a shadow. All right. And then if you move the light source away from the object, then what's going to happen? You are going to see a faint shadow. Okay, it's going to appear small because the light source is further away. And then opaque object cast shadows on the side opposite the one facing the what? The light source. For example, if we look at these pictures, these are nice pictures. This is a hand, and then this is the shadow. All right. It shows that the shadow is big, therefore it shows that the light source is near. And then the opaque object, that is your hand, is blocking the what? The light from passing through. Therefore, it's causing shadow. Even on this one here and this one, these are shadows of our hands. Why? Because our hands are opaque. They don't allow light to pass through. That's why we are seeing shadows. And then the other thing, if the light source is near, then the shadows will appear big like this. These ones show that the light source is near. But if it is further away, then what are we going to see? We're going to see very small shadows. Do you get that? We are going to see very small shadows, grade A. All right. Let's carry on. Most light travels through transparent objects, although some light can be reflected and absorbed. All right. Some light can be reflected and some light can be absorbed. For example, light is being reflected at illuminated objects like the moon. The moon reflects light from the sun. And then, what about absorption? If white light strikes a black substance, what's going to happen? No light is going to be reflected to our eyes, therefore we'll see it as black. Is that clear? Yes, that's good. And then light can be absorbed by surfaces of some materials. Okay, let's carry on. Light is absorbed differently by different materials, depending on the colors. Okay, and then a material has a certain color because it can absorb some colors and reflect others. All right. For example, red. We see red because if white light strikes an object, red is the only color that is going to be reflected to our eyes. Therefore, we'll see red. Okay. The frequencies that are absorbed by objects do not reach the eye. Okay. And then this is white light coming in on this picture. And remember the colors of the visible spectrum. These are Roy beef. All right. And then if they hit a surface, for example, a black surface, and there is no light that is being reflected to our eyes, what are we going to see? We are going to see black. And when white light is coming in and hits a yellow surface, the yellow light is going to be reflected to our eyes. Therefore, we'll see yellow. And then opaque and transparent windows. If it is an opaque window, we won't see anything. If it is a translucent window, we'll partially see an object. But if it is transparent, light is going to travel through. We're going to see the image on the other side. Why? Because light is traveling through. Okay, we are going to entertain your WhatsApp questions now. Remember to ask WhatsApp questions if you don't understand anything. Please don't call the number, but ask by texting. The number is 064 748 8913. Let's check your questions, grade 8. It seems we don't have questions today. Therefore, we're going to go on with our lesson. All right, we're going to look at the absorption of light. We're going to see transparent and opaque objects. Okay, let's see. We've got our homework, which I'm going to give you some time to copy. I'll just give you 3 minutes to copy the homework. Hope you are done copying the homework, grade 8. Remember to go and do your homework at home. All right. Then our brief preview of the next lesson. In our next lesson, we're going to explain reflection of light and seeing light and refraction of light. And then our reminder, make sure at the end of this lesson, you're going to press complete to show that you have completed the lesson. Thank you very much, grade 8. Hope you enjoyed the lesson as I did. Remember to always sanitize, maintain social distance, and put a mask, and be kind to yourself. So long for now.